initial video where we discussed the first 3 steps necessary to completing a hypothesis test problem where we use z-score test statistics. So if you haven't had a chance to watch that first video, please go ahead and watch that video before watching this one. And I think it'll be clearer the way in which we're introducing this material, and I think it'll be more understandable, more beneficial for you. We began the first video by trying to talk about how hypothesis testing can be helpful, not only in statistics, but just generally a variety of different industries and applications where you could use this technique. We used an example because I love basketball. I said in the first video that Kareem Abdul-Jabbar was the best, in my opinion, basketball player of all time. And I said that I believe that I could get at least 20% of the population of basketball lovers to agree with me. All right, so how would I do that? Would I go to every basketball fan in the world and come to that conclusion? Obviously no. But what we can do is we can make some inferences using statistics to poll, ask people, who do you think is the best? Who do you think is the best? And we can determine a certain level of confidence that we'd like to be, and we can make some pretty good predictions. That's what inferential statistics and this specific topic of hypothesis testing is all about. And we also had another example where I said that Lou Malnati's is the best pizza in Chicago. That's where I'm from, Chicago. And I doubled down and I said that at least 40% of the people in Chicago would agree with me. Again, how would I be able to verify that claim? I would use statistics. I would use this hypothesis test. I would conduct a poll. I would poll as many people as I could. I would have to poll everybody. How challenging would that be? But I'll poll a number of people, and I use some tables, which we'll introduce later, some low-level math, some formulas, and we would either reject that initial claim that at least 40% of the people like Lou Malnati's pizza, or we would accept that claim. So I'm very excited to present this. Again, if you haven't seen that first video, please go ahead and watch it. I'll put it in the link below, and you can check that out as you're able. All right, so enough talking. Let's get into step 4, calculating the test statistic, which will, for our problems, always be a z-score. The formula for a z-score is z is equal to x bar, that's the mean of the sample, minus mu, that's our null, divided by the standard deviation, divided by the square root of n. Standard deviation of the sample, S is the standard deviation of the sample, and n is the number of data that were collected. All right. So it's not too difficult a formula. All this information is given within your problem. All right. So you have an equal to sign. The mean of your sample, according to the first sentence, was 158. We subtract our null, which was 156. We divide that by the standard deviation of the sample, which was given to be 5. And then we'll divide the square root of the number of data that were collected within the sample, was 46. So hopefully You don't see that it's too bad at all. You end up calculating, you have 2 divided by 5 over radical 46. The square root of 46 is 6.78. 6.78. And you end up with 2 divided by 5 divided by 6.78. And you end up with 0.737. 0.737. You divide these two, and you end up with a z-score of 2.71. 2.71. All right. And that's that. Okay, that's that. In this particular video, I'm going to attempt to bridge where we left off with this video here. In the previous video that I really hope you get a chance to watch, we calculated something called a critical value. And critical value was, as I recall, for this problem, 1.28. But we never really talked about where we got that from. I told you that we would use, we had that normally distributed data, and we had a right-tailed test for this problem. And I told you that the rejection region we put, because we had a 90% level of confidence, that would be 10% of your graph over here. We said that the area under this curve was 1, so that to the left of this critical value, we had 0.9. All right, we had 0.9 there. So that 0.9 we're going to use. We're going to use that 0.9 to figure out what this critical value was here. The critical value, we said, like I said earlier, was 1.28. And I want to use this time now to talk about where that came from. How did we use this 0.9? This area to the left of the critical value. This area left of this border, if you will, that's separating the rejection region to the failure to reject region. All right. So where did this 1.285 come from? Where did this 1.285 come from? Let's talk about that right now, using that 0.9 there. All right, so let me get rid of this and talk about that. So you look for, it's a positive z-score table, you look for 0.9 within, within this z-score table. And I'm sorry that the print is a little bit small. I'm sorry about that, but I think if you look very closely, you could see that 0.9 would be in this area right there. All right, this area right here. All right, because here you have 0.8997, and to the right you have 0.9015. Now the z-score that corresponds with that, would be the 1.2. All right, so you get the ones and the tenths place, and the hundredths place, this would be 0.08 and 0.09. 0.08 would be too small, 0.09 would be too big. So I just sort of went halfway in between. So I got the 1.2, and I went a little bit higher than 1.208 to get 1.285. So in the first video, I did not talk about where the 1.285 came from, but I'm doing that now. It came from this table. All right. So that said, let's move on to the next problem. So we calculated the test statistic, but I just sort of went back in the process by actually showing you where the critical value came from. I hope there's no confusion there. All right, let's move on to the next problem. Oh, sorry about that. Let's get rid of that. So let's do the same thing here. Let's calculate the z-score. We're going to end up using that z-score that we're calculating in step 4, and we're going to compare it to that critical value that we are calculating right now. All right. In fact, yeah, we'll hold off on that. All right. So the z-score here, same formula. We have the z-score of my z-score. Okay, I'm sorry, forgive me. So the z-score formula is x bar minus mu over standard deviation of the sample divided by the square root of the number of pieces of data that we have. Same formula. If you feel like you can pause the video or do it on your own, feel free to do that. The mean of our sample here was given as 38. That mean is actually less than the average, which is thought to be 40. The standard deviation of 10 is given within the problem, and the number of pieces of data, take the square root of 100. All right, so hopefully this is not too bad. All right, so we have a -2 divide 10 divided by square root of 100, which is 10. We have -2 divided by 1, and we end up with a z-score of -2. We end up with a z-score of -2. We're going to use that z-score and compare it to the critical value, which we told you earlier. We told you earlier in the first video that coincides with this one that we're working with now. We said that our critical value was -1.645, but we didn't tell you where it came from. We didn't tell you where it came from. We're going to tell you now, though, where it came from. Where did this critical value of -1.645 that we're going to compare to our z-score, where did it come from? Well, let's show you. Let's try to use this space right here. We've got our normally distributed data. We had a one-tailed test that was to the left. All right. And to get the critical value, we look at this area to the left of this border that separates the rejection region to the left with the acceptance region that's to the right of this border. All right. This area, because we're working with a 95% confidence level, we said was 0.05. And that area to the left of the critical value is what we're going to use on the chart to determine what our critical value was. We know that it's negative 1.645 because I told you that, but I'm just trying to show you how I got that. All right, so let's get rid of that. So the focus is 0.05, that to the left of that critical value, 0.05. Let's get this out of here, 0.05. All right, go to the z-score table and look for 0.05. And if you look very closely, yeah, it's right in here, 0.05, right in there. Again, I apologize for not making this as clear, but maybe you could go to a negative z-score table and see it a little bit better. But 0.05 would be in between these two values right here. All right. So the z-score that corresponds with these percentages would come from right here. The negative 1.6, that gives you the ones place and the tenths place. So this would be 1.64, which would be the z-score that corresponds with that percentage. It's a little bit too small. Negative 1.65 would be the z-score that corresponds with this percentage on the right, would be a little bit too big. So what I had given, what I had listed in the previous video was our critical values negative 1.645. Negative 1.645. But I didn't talk about where that value came from. I'm doing that now. I would encourage you to get that critical value within the third step. Does it matter? Not really, but just so long as you compare this critical value with the z-score test statistic that we just gave you. All right, let's move on to the last one and focus on this calculation of a test statistic. Let's get rid of this. There we go. Our z-score is x bar minus mu divide standard deviation over the square root of the number of data. So our mean of the sample was 5.7. It's below the mean, so that's why we have a negative z-score, -6. We're going to end up with a negative z-score, excuse me. The standard deviation was given as 3.5 divided by the number of people, number of samples, number of people who were polled, I should say, number of people tested, if you will. I think that was given as 160. All right, so we have negative 0.3. Let's divide 3.5 divided by the square root of 160. That's 12.649. All right. So, what we end up with here is negative 0.3, and let's divide the 0.276, and let's divide that out. And what you end up with is a -1, -1.1 roughly, -1.1. It's actually a -1.0. 0.08. All right, so that's our test statistic. Sometimes that's a get your tongue tied there. That's our test statistic. All right, our z-score test statistic. So that is going to be compared to the critical value. That's going to be compared to the critical value that we gave you. We just gave it to you of negative 2.575, but we didn't talk about where it really came from. Okay, and we're going to do that right now. We're going to do that right now. So we have this was a two-tailed test. All right, this was a two-tailed test. The level of significance was 0.01. The level of significance was 0.01. We had two rejection regions. So this is 0.005, and this as well was 0.005. The area under this curve we established was 1. So that would mean that the area in between the rejection region boundaries would be 0.99. So I've really tried to emphasize the way you get these critical values is to examine the area to the left of this boundary. Examine the area to the left of this boundary. One area here is 0.005. The area to the left of this boundary is actually 0.005 plus 0.99. So that area would be 0.995. Each of those individual areas, the 0.005, you'd look on the negative z-score table because it's to the left of the mean, and the 0.995, which is to the right of the mean, that would require a positive z-score table. Both of those percentages would give you the z-score that I gave you for the critical value of negative 2.575. So again, you're focused on 0.005, the area 0.005, and 0.995. Those are the percentages that we're going to observe to get these critical values. All right, so let's take a look. Let's first clear this out. Move on to the next slide where we should have a z-score table. And let's look at the 0.005. Let's look for 0.005. And I believe if you look closely, 0.005 would be somewhere in there. 0.005. Okay, and this percentage would be a little bit lower or a little bit higher. This percentage would be a little bit lower. So we go somewhere in between. All right, somewhere in between. I think the z-score we're looking at here is negative 2.5. But negative 2.57 would be too low. And negative 2.58 would be too high. You go somewhere in between. So the z-score for the critical value that I gave you was negative 2.575. That's what I gave you. The first video, we didn't talk about where that came from. Hopefully you're clear. You examine that area to the left of the critical value. All right, but that was for a negative z-score. There was another critical value. That was to the right of the mean. So therefore, you would need a positive z-score table. And let's go to the positive z-score table real quick. Let's get rid of that. Okay, and then we need an area. I told you you needed to look for the percentage 0.995. 0.995, maybe that would be somewhere in there. 0.995. This is a little bit low, 0.9949. That's a little bit low. A little bit high, 0.9951. Somewhere in between would be the z-score that we would want for our critical value. And notice how you end up with the 2.5, and then you got the 2.57, 2.58 positive, and somewhere in between would be the 2.575. It would be the opposite of the z-score that we got on the other side for the other critical value on the negative side. You don't have to find both critical values because that symmetry will always exist. I just thought we'd do it just to get a little bit more practice. So I hope it's clear. I hope we successfully made that connection between the critical values that we calculated in step 3, actually. All right, so we're going to move to the fourth. We're going to move to the fifth step, the final step, where we begin to draw some conclusions. We begin to make decisions on whether we're going to accept or reject the initial null hypothesis. We're at the very, very end of the problem. I hope that fourth step was clear. I hope that was clear and understandable. All right. So on to the final step. Let's try to decide whether to reject or fail to reject, or another way to say that is to accept the null hypothesis. Okay. All right. So first problem. What do? Basically, what we're going to do here is compare step 4 with step 3. All right. So let's go ahead and do that. Let's go ahead and do that. All right. So we have normally distributed data here. All right. For the first problem, we had a rejection region that was on the right side. Our critical value that we showed you how we got it, the previous step, was 1.285. 1.285. That was our critical value. We had called to the right of that, and sort of the border that separates what we call the rejection region from the acceptance region. Sometimes it's said failure to reject region. Anything to the right of the critical value will reject it. Anything to the left will fail to reject it or accept it. Our z-score for this sample, our z-score in the previous step, we calculated it, as I recall, to be 2.71. 2.71, which is to the right, this critical value. I don't know if you can see that real good, but that critical value is 1.285. This z-score is to the right of that. This z-score is bigger than the 1.285, which would mean that it fall to the right of the critical value, which would mean that we would reject our null hypothesis. Our initial null hypothesis, if you recall, our initial null hypothesis was that mu would be equal to 156. All right, so we would reject that. We would reject that null hypothesis and come to the conclusion that our alternative hypothesis would be what we would accept. All right, so our alternative hypothesis, we're rejecting our null hypothesis. We would go to our alternative hypothesis, which said that mu was greater than 156. All right, so our conclusion, which we would need to connect to the original problem, our conclusion would be we reject the null that our mean was equal to 156 and predict that the mean weight of the population would be greater than 156. All right. So you try to connect your findings to the original problem. All right. So that's that. That's that. All right. So I'm going to get rid of this and attempt to do the same thing. Decide and draw some kind of conclusion on the second problem. Again, this idea of really trying to solidify your understanding of this step. And once this step is clear, you tie together all of these subtopics. And I believe as you study this video and you look at other problems that you'll find online and so forth. And my hope would be that this video is helpful in making this topic clear. Let's get rid of this and look at the next problem. All right. Let's decide whether or not we're going to reject or fail to reject our null hypothesis. For this particular problem, our null hypothesis, as I recall, was that the mean number of the average number of customers was 40. All right. Mu was 40. All right, and our alternative hypothesis here was that mu was less than 40. That's what the salesperson was sort of predicting. All right, so how are we going to make some kind of conclusion? Got our normally distributed data, and one of the previous steps, we had a one-tail left, one-tail test on the left side. The critical value that we've shown you, we gave it to you initially, but we later showed you what that critical value was. We had a critical value of negative 1.645. That was the critical value right here. That was our critical value. That's sort of a border, which is going to separate the rejection region to region to the acceptance region. Sometimes instead of saying accept, the problems will say something like failure to reject. Same thing is basically same thing as accept. All right. So our critical value is negative 1.645. In the previous step, we calculated our z-score to be negative 2. So you have to ask yourself, where does negative 2 fall? Is negative 2 in the rejection side, or is negative 2 in the acceptance side? Well, negative 2 is actually less than negative 1.6. It's to the left of negative 1.6. So this z-score falls within the rejection region, which would mean that we would reject our null. Our null indicated that our mean, the mean age of the customers was 40. We're rejecting that and therefore accepting our alternative hypothesis that the average age of the customers was less than 40. All right. So in terms of a conclusion, all right, so we're going to reject the null hypothesis that the average age is 40 and predict the average age of the customers, of all of the customers, is less than 40. So again, I'm trying to, I'm not just saying something like we're rejecting the null hypothesis. Sometimes I've seen students do that. The goal would be to try to connect this back to the original problem and draw a conclusion that relates to the question at hand. All right, so we've got one more to do. Let's get rid of this. Let's get rid of this and move on to the final problem, where our focus is only on whether or not we're going to reject or fail to reject the null. All right, so in this particular problem, as I recall, the null hypothesis was mu was 6, and the alternative hypothesis was mu was not equal to 6. Okay? Mu was not equal to 6. All right, so we've got our normally distributed data. This was a two-tail test where we gave you the critical values and later showed you where the critical values came from of negative 2.575 and positive 2.575. Positive 2.575. Okay? And then what we are going to do is we're going to compare that to our z-score that we found in the previous step our z-score was negative 1.08. We identified this right side and left side as the rejection regions. All right, so what you have to do is you have to ask yourself, does negative 1.08 fall within these rejection regions, or is a negative 1.08 in between these critical values? I think you can see that negative 1.08 is actually more and to the right of this critical value right here. All right, so that means that we would, again, these critical values are separating the rejection region from the rejection region and the acceptance region. All right, so in this particular problem, we would fail to reject our null hypothesis. Another way to say that is we would accept this initial claim. We would accept the initial claim, which is good because we were supposed to prescribe 6 milligrams. When you're talking about medicine, you really want to be, you don't want to say, well, I was close enough, all right? You don't want to have that kind of mentality. Okay, so the way in which we would sort of conclude this problem, what we would say is we are accepting the null hypothesis equal to accepting the null hypothesis where mu is equal to 6 milligrams. Okay, we're accepting the fact that the infants are being prescribed the correct amount. All right, which would be 6. So that's it. All right, that's it. That concludes this video. The last thing that I really wanted to do is end with the infographic that we began with in the first video for the visual learners out there, and see if, after having discussed the 5 subtopics necessary for hypothesis testing problems, maybe the infographic, as we go through it, would make things even clearer. Let's see if that is the case. All right, so you got the person in step 1 here. Step 1 here, up here in the upper left, where he said, hey, I think something is true, but I'm not sure. Let me test my hypothesis with data. So we tried to connect this to basketball. Now you're going to go and you're going to ask a bunch of people, hey, who's the best player? And you typically need more than 30 pieces of data. You got to have more than 30 pieces of data. All right, and then you then go to step 2. Based off the alternative hypothesis, we tried to determine if we're going to have a 1 or 2-tailed test. That was topic. The second important step for this problem. Then for 3, We knew we had a normally distributed information here. We determined the level of, we actually, we determined a rejection region, failure to reject region. For number 3 here, they're showing a two-tailed test, but we also showed you problems that were not two-tailed tests. We did things like find the level of confidence, the level of significance. We did that. And then the 4th step was to use this formula, use that formula, which is a z-score formula. And we used that, and we made certain comparisons with the critical value, which we showed you how to do. And then we were very happy after that because we were able to make certain conclusions and predictions. I really, really hope that this was clear. If it was, make some comments. If you have questions on anything, make comments and we can address them. I'd love to entertain your comments or questions. I don't know if I put this on YouTube or not, but if you like it, and subscribe. All right, so take care. Good luck to everybody in your quest to dominate this inferential statistical subject called hypothesis testing. Good luck to you. Have a good day. Thank you for watching.